Hello friends, so this is the first video of my YouTube channel. Hope you would like it. In this video we are going to deal with a problem from the Soviet Union Mathematical Olympiad of 1973 that says if a 9-digit number is formed by the 9 non-zero digits and its unit is 5, prove that it must not be a perfect square. First of all, I want you all to try this problem. Pause this video, and when you're ready, keep watching. Now, from the information stated above, we can use 1 to 9 and not 0 as a digit, and the unit digit of that number must be 5. We can clearly notice the fact that when a number is of n digits, its square would always have 2n minus 1 or 2n digits. Clearly, if it is one digit, either it is two-digit number, its square, or a one-digit number. If it is 1, it starts with 1, and if it is the biggest one digit, and that is 9, it ends at 81. Similarly, if a number is two digit, that is it's right between 10 to 99, its square ends at 9801, and that is the square of 99, four-digit number 2n, and least it is 10, so 100, 2n minus 1. Similarly, I assumed, I erased the question by mistake. Here's the question. So let's assume that our number was ABCD5, a 5-digit number, because it was 9 is 2 times 5 minus 1 would be 5. We are going to prove this by contradiction. So let's you can multiply it row wise. I am multiplying it directly. 5 times 5, 25, 2 goes in carry, 10d plus 2. Now again it's 10c plus d square. Now this would be 10b 10b plus of 2cd, 10b plus of 2. Now I'm the fact that whichever number ends in 5, its square ends in 25. That's a fairly simple fact. You can prove it yourself. Just assume the number to be 10a plus 5, and you would arrive at the result very easily. Now coming to this question, uh, if all since 2 does not have a tens digit, always this d would be carried to this digit adjacent to it, to the rightmost adjacent digit. For example, if d was 1, it's 10 times 1 plus 2, 12, 1 gets carried. 10 times 2 plus 2, 2 gets carried. 10 times 3 plus 2, 3 gets carried. So simply we can write this number as 10c plus of d square plus of d. Now see this quantity right here, d square into d plus 1. It could be rewritten as d into d plus 1. This is a very interesting number. It is the product of two consecutive numbers. I would say digits, because these are digit lies between 0 to 9. So if d was 0, it again, one more thing, we are not allowed to use 0 ever. We have used 2, so not allowed to use it again, and 5 also. Except these three numbers, we can use any number. If d was 0, it's 0 times 1, 0. Not d can't be 0. If it is 1, 1 times 2, no, not allowed. 3, 3 times 2 times 2, 2 times 3, it can be possible. 3, 3 times 4, not allowed. 4, 4 times 5, not allowed. 5, 5 times 6, not allowed. 6, 6 times 7, not allowed. 7, 7 times 8, 7 is allowed because it ends in 6. 8, 8 times 9, 72, not allowed. 9, 9 times 10, again not allowed. So d can only have two possible values, that are 2 and 7. Let's assume in case 1 that d were to be 2. If d is 2, it would be 4 plus 2, 6, 10c plus 6. This digit would be 10c plus of 6. So it would be 10c plus 6. And since again with the same fact we used here, c 6 does not have any a tens digit, so C would be carried as it is uh, to the number adjacent to it. So this would become 10B. Since we assume D to be 2, it would become 4C plus of C from this number carried here, C. So this now this number is 5C plus 10B actually. 5C plus 10B. Now 5C plus 10B implies that this digit is a multiple of 5. 5 multiple, if it is a multiple of 5, this implies either this will end in 0 or 5, both of which are not allowed. So D can't be 2. Let's try the second case. If D were to be 7, if D were to be 7, this would end in 7 square plus 7 plus of 10C, this digit right here, and this one, that is this one with this D carried forward. So this would take this form, 10C plus 7 square plus 7, that would become 10C plus 56. So clearly from this, C plus 5 would be carried forward. If C plus 5 is carried forward, since we assume D to be 7, so this would become 14C, and if C plus 5 is carried here, so it would become C plus 5 carried. This again becomes 15C plus 5 plus 10B. This is again a multiple of 5. This must end in 0, 5, both of which are not allowed. So D can't be 7. Clearly, there should not exist any D, and if there does not exist any D, then it would be a 4-digit number. So its square would always lie between 8 to 7 digits, 7 to 8 digits, and which is not allowed. The number is a 9-digit number. So we have proved by contradiction that such number does not exist. Hope you would like the video, and this was an amazing problem. I would be uploading 2 problems per week. Stay tuned and please subscribe to my channel. Thank you.